Today I'm going to finish up Chapter 8 for you. This is 8D, pages 290 to 293, the last few slides, 24 to 30 on the chapter notes. This makes a visual, kind of easier way to get at whether one of the statements is true or false based on something else that's true, how to move things around and get equivalent statements and things like that. And so back when we were looking at the Venn diagram showing us when things are equivalent, this is an easier way to kind of show, oh, well, if this one's true, then this one's false, whatever. So I'm going to get around to that. So please do not look these up online somewhere else. We're only using the things that are on the page, and this is page 290. Yes, there are more complex versions of the square of opposition. Please just stick with this one. Use what we have in the book. It's what's going to be on the test. It's what's going to be in your homework. If you use other forms, sometimes they can lead you astray. So stay focused on this one. It's about enough to get on with too. So anyway, the square of opposition is, like I said before, a visual representation of the truth relationships among these four statements. And so 4 statements, it's a square, of course, the square of opposition. And so it sounds like some sort of torture device, but it's not really. It helps us out. So A is the top left, E is the top right, I is the bottom left, O is the bottom right. Okay. Now A and E, all SRP, no SRP, they can't both be true. Okay, that's just, you know that. If something is all red, it can't also be all blue, or else you got purple, right? But you have contraries. The A and E are contraries because they cannot both be true at the same time. Okay, so if A is true, E is false. If E is true, then A is false. Okay, they can't both be true. Now, there's a whole lot different thing with that. I'll show you in a minute. The bottom half, the I to O, are subcontraries. They're on the bottom. They're not both false. Okay, so some SRP, no, some S are not P. They can't both exist at the same time, right? You have that. So not both false. Not both false. Sorry, they can both exist at the same time. They can both be true. They just can't both be false. Now, the other thing that's helpful about this is how we get from corner to corner. Sometimes you have to go across the middle. And these are contradictories. So an A and an O can never have the same value. Okay, so if A is true, O is false. If O is true, then A is false. Okay, so you have lots of ways to figure out how this works. Same thing with I and E. They can never be the same. They're contradictories. Now, when you're given an assignment here, it's going to be something like this. So all SRP, semicolon, some SRP, okay? And what this formulation gives you is this statement, the first statement, is always true, okay, when you're given these questions. All SRP, okay, so that's true. What's this? Okay, and I'm going to show you how we get there. So if I'm starting up here on A, okay, this is true, but I need to get to I. On this square, we don't have a direct root, so we have to kind of cross and pollinate here. So I can either go A to O, okay, and I could say if I go from A to O, this one is false, right, because they're contradictories. Now, because this one is false, I can go over here to I and say it's true because they can't both be false. Okay, so I can draw it. And I go this way, and then I go this way. Okay, that's my drawing. Okay, so my true starts here, and I end up true here because that false is in the middle. Okay, or I can say, since this A statement is true, then the I statement, oh sorry, I have to do the steps. Then E is false because because they are contraries. Okay, E is false. And I is true because they are contradictories. So pick the way that makes the most sense to you, and when you're given one of these, give me one or the other, okay? You have to draw it, or you have to give me that particular kind of daisy chain of information so that I can tell you what they are, okay? Now, I think I have it up on the notes, but I do have the patterns. So these things, okay, so if my first statement is true, okay, so if A is true, then E is false, I is true, O is true. How is O true? Hold on. If A is true, E is false. Sorry. Oh no, he has to be false. That's true. Sorry. I have it wrong in my little notes here. Oh, I was looking at the wrong guy. I have it right. I'm sorry. It's one of those days. Okay. So there's my first one. If E is true, then I is false. A is false. And O is true. Okay? Now, with our universals, we get definitive answers. Okay? With our particulars, sometimes it can be a little bit weird. So if I is true, then E is false. That's easy. A is what we call indeterminate. Or you can just go true or false. And since A is indeterminate, then O is also indeterminate. Partially, okay, so if I'm starting down here, this is true, and I go up to E, it's false. Well, I can't say that A is true or false because they can both be true. They can't both be false, okay? But they can both be true, and so I can't tell, they can both be false. They can't both be true. So I can say this would be either false or true, and then since that one's undeterminate, so is this one, okay? Same thing happens with certain things in O. So if O is true, then A is false, right? E then is indeterminate. Could be true or false because they can both be false, but they can't both be true. And then because E is weird, indeterminate, then I is indeterminate. So sometimes the rules help us be definitive, and sometimes they're not. Now, the diametrically opposed, right? You go from side to side, you're can't never be the same. It's when we have to go across to get places that we might end up with something that's indeterminate. So if your question starts with all SRP or no SRP, everything's going to be determinate. Okay, it's going to be true or false. Okay, if your first statement is some S are P or some S are not P, then unless it's the opposite corner, indeterminate. Okay, so keep that in mind when you're looking at these homework questions and things, and it'll make more sense, I promise. Okay, let me make these go away and show you some other things. When we talked earlier about equivalencies, we were drawing out two different sets of bends, right? And that's how well it works. But there are certain things that we know work. And so there are three categorical equivalencies, okay? Conversion, I'm going to show you what those are. And they're equivalent for E statements and I statements only. Contraposition is equivalent for A statements and O statements only. Obversion is equivalent for all four, okay? So I'm going to read some things to you. I'm going to show you some things. So conversion, okay, switch the subject and predicate terms, and that's it. That's what you do, okay? So when we were doing the I's and E's earlier and making the two sets of circles, those are the ones that work, okay? So switch S and P. So if I have, as my I statement, some students are penguins. And I'm supposed to make it a conversion. I'm going to just flip my subject and predicate. So some penguins are students. And these are equivalent. Okay, same thing. We do the same thing with E. No students are penguins. And no penguins are students. Okay, because I'm just, again, my S and my P becomes P and S. Okay, so they just flip. Those are always equivalent. A's and O's, not so much. Okay, obversion, everybody's equivalent. Okay, so obversion works because when we say a class of something, we implicitly label everything else as a non-this, right? If I say all cats are carnivores, I'm saying everything that's not a cat could not be a carnivore. Okay, so there's all kinds of things there. So you're going to replace the predicate term with its complement, non, okay, and switch qualities, positive to negative or negative to positive. So you're going to replace the predicate term. I'm trying to write predicate and term at the same time. With its complement. Okay, and switch qualities. Sorry, I have to get the right word there. Okay, so positive to negative or negative to positive. Okay, so, and everybody's equivalent, so I'll give you a whole bunch of things here. So an A statement, all mugs are black until I made these up. I have a black mug at home that I use all the time. Are black. Now we have to make it a noun, so things. Okay, so I'm going to make this, my predicate term, non-black things, and I'm going to switch to no, because I'm switching from positive all to negative no. So it goes like this. No mugs are non-black things. Okay, That's equivalent. E, no mugs or black things. Okay, and we're going to do the same thing. So non-black, but it's going to be back to all. Well, it's going to go to all. So all mugs are non-black things. Okay, that's equivalent. My I statement, some mugs are black things. Should have stuck with the cats, right? And then I'm going to go back to my non-black things, and some are not. Okay, so that's why I go negative on this one. Some mugs are not non-black things. Okay, so even though you need to leave that alone. Okay, our desire is to fix that, right? Not non. But in this case, leave it like it is. Okay. And then our O statement. Some mugs are not black things. And we're going to change that to some mugs are non-black things. So why does this make a difference, right? Well, it does because not is an adverb and non is an adjective. 5th grade grammar again, a little bit messy. Okay, so these are all equivalent because every time you do an obversion, it's equivalent, all 4 types. Now, contraposition is another kind of odd little guy. Okay. Contraposition is kind of everything all at once. Reverse the positions of the subject and predicate terms and substitute complement terms for subject and predicate terms. Okay. It's only equivalent for A's and O's, so we're going to do those. Okay, so we're going to reverse positions of S and P and substitute complementary terms, complements for terms, sorry. Okay, so if I have all napkins are red things, okay, this is my A term. All napkins are red things, so I'm going to flip my S and P. So all red things are napkins. All non-red things are non-napkins. Okay, so like I said, we're going to do everything all at once. All non-red things are non-napkins. Okay? And that's equivalent. Everybody's, that's what we're doing. Equivalent. O, some napkins are not red things. Okay, so we're going to flippy-flop here. So we're going to do some non-red things are not non-napkins. And it's equivalent. Okay? Not horrible, a little bit weird. Those are the kind of easy, quick. Now, let me explain something easy here, right? Even when this doesn't make sense in your head, this is true. Okay, these are givens. They are true all the time. Same thing for obversion. If you do this, it's equivalent. You don't have to think about it. You don't have to justify it. It just is. Okay, same thing here for the A's and O's for contraposition. This is just the way it works, right? Now you can see things, especially here with the A. Okay, so all napkins are red. All non-red things are non-napkins. It's the same thing, right? Because we have that idea of what we don't say is everything else is not, whether that's true or not. So keep that running around your head. I put this, well, the contraposition, reverse positions of S and P and substitute complements for terms, their definitions on the back of that card that has the circles. And I also have the square of opposition on the back of that card. Now you can make 3 different cards. It just depends on how many pieces of paper you want to keep up with. It's nice to have them kind of sitting there because that way you can just do the homework and move on. Now, obviously, it's only a couple pages away, so if you don't mind flipping, there you go. Okay. I hope this has been helpful. I am going to have, of course, a homework one here in just a minute or two, and we'll see how that goes. Let me know if you have trouble. You know how to get a hold of me, right? Email works really well. So